Fuses and circuit breakers protect the wiring and components in an electrical circuit from short circuits, okay? Fuses and circuit breakers, those are our main two types of overload or overcurrent protection devices, okay? You've got several. You've got the screw-in base, you've got cartridge, you've got knife base. These are all fuses. And then these are circuit breakers right here, okay? Fuses come in many different sizes, shape sizes, so do circuit breakers. The thing that's interesting about them is how much current they can actually interrupt. You see a rating that says AIR. That is their interrupting rating. Okay, their ampere interrupting rating. Okay. That's how much current, short circuit current, that they can interrupt reliably. Okay? So if I look over here at this panel, there's a little yellow sticker with a star on it. It says that I can safely interrupt 22,000 amps. Okay? 22,000 amps, my main breaker can interrupt safely or reliably.
So anything under that, it'll trip?
Anything under that, it will work 100% of the time. Anything above that, it should work, but it may not.
Is that kind of in the instances where the breaker will fuse together and it won't trip?
Right. That's what it's talking about. If you have such a high short circuit rate or short circuit that it's above 22,000 amps, then you have the you have a chance. I'm not saying likelihood, but you have a chance of it fusing together or just failing to open.
So
that's bad.
There would be an AIR on fuses and circuit breakers?
Most of your circuit breakers, I believe, are 10,000, and the remaining is 20. Yep. Look on the side of your circuit breaker, there's an interrupting rating, 10,000 amps. Okay. So of course, this is going to interrupt less than my main will have to. That just makes sense.
So basically, it's saying like it'll still trip at whatever the
Right.
breaker's rated at, but if the overcurrent is over
Right.
so much,
And we'll do some short circuit calculations, so you can see when you run a hot to a neutral how much current it actually passes up through it. You know, for a split second. I mean, we're talking about milliseconds. For that millisecond, you're sending out 5, 7, 10,000 amps for that short second.
yeah, is that what causes like the arc blast and stuff?
Right. It's how much this can interrupt and how fast this interrupts it. Because if this were to fuse with 20,000 amps running back through it, it's bad. Okay. So that's the interrupting rating. You will need to know what AIR stands for. All ungrounded hot conductors shall be protected against short circuits and overloads. Short circuits and overloads. Okay? When we get talking three-phase, we use motor starters, which provide overload protection, but they don't provide short circuit protection. Okay? For any hot conductor, it has to be short circuit and overload protected. Okay? Fuses and circuit breakers do that. They allow us to protect against short circuits and overcurrents. Okay, that's why they're used so much. Looking like he's going to ask a question. Plug fuses shall not be installed in circuits operating at 150 volts to ground. Plug fuses, I've got one here. They were used commonly back in the day. Okay, anyone know what they used to call them? The Edison base. That's the size of the threads. If you ever see an Edison base or hear of an Edison base, that's just talking about how big a base it is. Okay. Then you have candelabras and you have C2s. Those are like your Christmas lights. Okay. Edison base is talking about how how big this base is.
They used to refer to this as a light bulb fuse.
Light bulb fuse. There's an old saying, back in the old day, about what size this was. You want to ever hear the penny size? Nickel size? It used to be called penny size. You could put a penny in there and it would fit perfectly. And so you didn't need a fuse. You could use a penny. And thus your lights would never trip out.
Not very smart.
No, it's not smart. That's what they did back in the old days. Called them penny size. Okay? So these fuses are not for anything over 150 volts to ground. Okay? A lot of people say these are terrible. Okay? I want to change these out and I want to put in circuit breakers. Why would you use a circuit breaker instead of this fuse?
Cheap reset the switch.
Resettable, right? This blows up, you throw it away, you got to put in a new one. Circuit breakers, something happens, I overload my shed, trips out, I just reset it. Once the overload condition is gone, I reset it, I'm good to go again. This, I'd have to screw in another one, and I tripped it a lot this summer since it's 150 degrees every day. So I'd go through a lot of fuses. But I like fuses.
Why you put a pin in there?
What?
That's why you put a pin in there.
That's why I put a pin in there. Okay. I never have a problem until my wires are melted.
Burn the whole thing down.
Yeah. Fuses are good. They have their place. Because they never fail. These cannot fail. They melt, they're done. There's no bypassing, there's no nothing. Once something happens to them, they're done. Circuit breakers, how many short circuits to this circuit breaker am I guaranteed that it will work after? There's a number. What?
10,000.
No, if I short circuit against it blank amount of times, after that it becomes unreliable.
One time.
Nope. 2. If I short circuit, which means a hot to a neutral 2 times against this breaker, then it should be taken out of service and replaced, because it has now become unreliable. Okay? And that's from the manufacturer.
Why is it only 2 times?
Because after that the spring in here becomes weak. You may trip early, you may not trip. Okay? After 2 times, because when we do our calculations in a couple days, you'll find out that it's just a simple short circuit is 7,000 amps. You know, this is only rated to handle 20, or trip at 20. So you send 7,000 at it, it's going to trip faster. That's going to hurt it. 2 times, and then this is inoperable. How many people have ever taken a circuit breaker out and thrown it away and put in a new one? You have?
Yeah, but they were bad. They wouldn't stay on.
Ah, so they become inoperable.
Yeah.
Okay? I know that a lot of industries have short circuits, and they just fix the short circuit and keep going. I don't want to trust my life to something mechanical. I'd rather have a fuse that protects me. But I don't have a fuse panel either. I have circuit breakers. I also value money. Yes?
If you wanted to, can you just put, like, double it up?
Double what up?
Put 2, what's that? Of the switches.
You mean connect them in series?
Yeah.
Or parallel? You could.
So then just pieces of line, in case one fails, you have the other one.
Seems like a lot of work to me. You do what you want.
We'll be back right after this.
Cartridge fuses are designed with either a ferrule or a knife blade configuration. So here's a little cartridge fuse. Same thing that we use in the industrial labs, right? It's nice and pretty. This is what it's called, a cartridge fuse. What? Right. Okay, on here it will tell you everything you need to know about this fuse. It will tell you the ampere rating. It will tell you if it is a time delay or non-time delay. Okay, it will tell you who makes it. Okay, so whenever you're replacing these, you need to match this number. 20. This happens to be a 20 ampere fuse. You got to match that almost perfectly with what you're putting in. Okay, that is a key thing. Don't ever, unless you go smaller, don't ever put in, this is 20 amps, it's 20 amps for a reason. Don't put in the 30 amp. That's bad. That's really easy to do, especially if you're in a pinch. If you're out working late night at Simmons or Camoplast or Tyson's or something, and you blow a fuse, and you can only find a 30 amp, and this machine won't run, don't put in a 30 amp when a 20 amp is needed. Because then, possibly your wires become your weakest link. That's bad. Because then they fail, then you've got even bigger problems. Okay? Always match the conductor ampacity to your overcurrent protection device. Okay? Non-time delay fuses can detect an overcurrent and open the circuit almost instantly. Okay? These are the best types of fuses. Non-time delay fuses. Why? Why would I want a time delay fuse? That seems like a bad idea. To allow current to spike.
If you're running a motor that's gonna...
Oh, a motor! On a motor circuit, this is my sine wave. Okay? Remember, when you start a motor, it's going to spike really high and then come back down into the range. So you need a time delay to allow this spike, one cycle. Okay, you've got to allow for that cycle so that your motor can get running. Because if you don't, if you put in a non-time delay, as soon as you turn on that motor, every time you trip it, you won't even get your motor started. Done. Hit the button. Done. Okay, because it's a non-time delay. Time delay fuses are used in motor circuits. Non-time delay are used everywhere else.
Do they have circuit breakers that are time delay as well?
Yes. They sure do. Okay, so inside these fuses, you've got kind of a breakdown here. You got a single element. I show you have these little notches in here that you can kind of see. Okay, those little notches, what are they good for? What are they used for? Why do we have notches in them? Why don't we just have one single piece of copper?
These notches are the weakest spot to break.
Why?
This is a smaller path for the current to flow, which creates more resistance. That's where it's going to burn up easier. It's going to get hotter easier.
It's going to get hotter easier. These little thinner pieces have a lower ampacity, right? It's just like if you take this wire versus a 12 gauge wire. Okay, which one's going to burn up first? 12 gauge wire, right? Because this one's a lot bigger. Okay, same thing with that fuse. This is going to have higher ampacity. Then when you get to that little bitty neck down area, that's what's going to melt. Okay? Dual element fuses, basically like the single element fuse, except we have two of them, one for overcurrent and one for short circuits. Okay, so each one can detect either one. But we're going to cut them open here a little bit. Okay, so you can kind of see. So inside here is just not, a piece of copper. There's some junk in there. Okay, to help dissipate that heat.